In this video, we're going to talk about simplifying numbers under square roots. So obviously you can have different roots and the same idea will work, same ideas will work, but we're just going to look at square roots in this one. So there's a couple main properties you need to know. Namely, if you have the square root of a product underneath, so a times b, you can break that up into the square root of a times the square root of b. Likewise, if you have a fraction, the square root of a divided by b, you can break that up into the square root of a divided by the square root of b. One thing that I think is pretty useful to know to do square roots is knowing squares of numbers. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and I've got them all 7, 8, 9, 10, 11, 12 squared. These numbers are kind of important numbers to recognize because if you see those, you've got a perfect square. So all of these numbers in red are going to be numbers that you're going to want to be familiar with. If you recognize these, it'll make doing a lot of these problems, I think, much easier. Alright, so let's start doing some examples here. Let me find my first example I want to do here real quick. Okay, so I'm going to take an easy one here first, really to illustrate an idea more than anything. Okay, the square root of 9. Well, the square root of 9, that means we need a number times itself that equals 9. Well, the square root of 9 is 3, because 3 times 3 equals 9. Suppose you didn't recognize this. Kind of the pattern that's important is the following. Notice you can factor 9 into 3 times 3. The idea underneath a square root is if you see a number twice, you can basically pull it outside of the square root once. And you can think about there still being a times 1 underneath here. So you're left with 3 times the square root of 1, which again is just 3. So an important idea is to factor numbers down, and if you see pairs of numbers, you cross out a pair and bring it out one time. Alright. So another important little idea here, same thing, the square root of 5 times the square root of 5. Well, we can use this property from before that says if they're under their own little house, you can put them under the same house. So if they're under their own individual square root, you can put them together under the same square root. And I'm not even going to multiply them. The square root of 5 times the square root of 5. I'm going to use the same idea as before. I can cross out a pair of 5s and pull that out front as a single 5. And it's not like you're just left with 0 underneath. You're going to be left with just a 1, but the square root of 1 is just 1. Or you get 5 times 1, which is 5. So the other idea here that's important is if you see the square root of something times the square root of something, you basically just are left with what's underneath the square root in the first place. Alright, so let's do some more complicated examples here. Alright, so the square root of 20. Alright, I don't know a number whose square root is 20, but I can break 20 down as 4 times 5. And now I'm going to get rid of the 4. I know the square root of 4. The square root of 4 is equal to just plain old 2. So I'm going to get rid of the square root of 4 and pull that out as a 2. And then I'm still left with the square root of 5. Well, you can't break 5 down any further. It's just 5 times 1, which really doesn't help. So this would be considered kind of a more simplified form of square root of 20. Alright, so suppose we have square root of 48. Well, maybe there's better ways to do it, but I know that 48 is certainly even, so I'm going to write that as 2 times 24. Well, I don't know square roots of either of those numbers, so I'm going to write, you can't really break down 2 any further, it's just 2 times 1. But I can break 24 down further as 2 times 12. And now I'm going to use this idea, I've got a pair of 2's. I'm going to pull that outside of the square root one time. So I still have 2 square root of 12. And now you have to ask yourself, can you keep breaking down the 12 any further? So there's my 2 out front. Well, I can break square root of 12 down as 4 times 3. So here's my original 2, but now I'm going to get rid of this 4 because I know the square root of 4 is just 2, and then I'm left with a square root of 3 underneath the radical. Okay, well, I can multiply out front. 2 times 2 is 4, and then I have my square root of 3 left hanging out, and you can't really break 3 down any further, so that would be your answer. 4 times the square root of 3. So let's do another one here. So I've got square root of 160. Well, again, this is even, but I even recognize that this is 4 times 40. Same idea as before. I can pull out the square root of 4 as a 2, and then I'm left with a square root of 40 hanging out. I don't want this to run into my next example down here, so let me try to stay above here. And I can break 40 down further as 4 times 10. So lots of 4's floating around in these examples. I can pull out the square root of 4 out in front of the square root, again, as just a plain old 2. And if you think about square root of 10, you can break that down into 2 times 5. Neither one of those are square roots. You can't break it down any further. But I would multiply out front and get 4 times square root of 10 as my final answer. Okay, so here we've got square root of 8 times square root of 10 in our next example. So neither one of these I can take a square root of, but we can put them under the same square root. And I don't multiply them out because you're going to want to start breaking them down in any case. So I can write 8 as 2 times 4, so there's my 8. I can write 10 as 2 times 5. Well, I see a couple things going on here. One is that I can pull out a square root of 4 as a 2, but then I also see a pair of 2's. And again, this idea that if you see a pair of something under a square root, you can pull it out one time. And then I'm still left with a plain old square root of 5 hanging out underneath. Well, again, 2 times 2 is 4, and then I'm left with my square root of 5. And that would be your final answer. So a lot of 4's coming out front here, so sorry for all the 4 examples. So let's do another one here. Keep making examples till I run over my 10-minute time limit. So here I've got square root of 14 times the square root of 21. Again, I can make this the square root of 14 times 21. And now, same idea. I'm just going to break things down. So obviously, you may notice you need to be real good with multiplication just so you can factor these numbers down. Otherwise, you're going to have a pretty hard time doing this. So if your multiplication skills are a little rusty, my first suggestion would be to go practice. You know, make sure you know your multiplication tables. It'll make life so much easier for you. So I'm going to break down 14 as 2 times 7. I can break down 21 as 3 times 7. And now the same idea. I see a 7 and a 7. I can pull that out front one time. I'm left with a 2 and 3 underneath there. Neither one of those have square roots, at least not whole number square roots. And you can't break 2 down any further, 3 down any further, so 2 times 3 is 6. I'll stick them back together, and that would be my answer, 7 times square root of 6. Okay, so in my next problem, I've got the square root of 100 over the square root of 25. So a couple different ways to do this one. You could notice right off the bat that the square root of 100 is 10. The square root of 25 is 5, which gives you 2. Just kind of another way to do this one to illustrate. You can also make this the square root of 100 over 25. Well, 100 over 25 is equal to 4, and again, the square root of 4 is just plain old 2. Alright, so maybe just another one in this same idea. Suppose we had the square root of 50 over the square root of 2. So in this case, I can't take square roots of either one, but I can write this as 50 over 2, which is the square root of 25 which is just going to leave me with plain old 5 as my answer. So sped this last one up. I notice I'm over the 10-minute time limit, which is the limit for YouTube. So I hope these examples make some sense. If you have some questions or would like to see some more of these, feel free to shoot me an email via my YouTube account, and I'll be happy to answer them for you.